Grade 6, this is the math video for page 235, which is labeled as a green practice test on the page. Number 1 says, which of the models at the right represent a greater fraction? Well, how many squares does that cube have? Doesn't it have 100? How many of them are shaded? Isn't 70 of them shaded? So couldn't we talk about the fraction 70/100ths? And then that other fraction. Didn't they shade 5 out of 7? Yeah. What they're really asking you to do is to figure out which one of these fractions is bigger. If it were me, the first thing I would do is I would simplify this fraction to make it easier to work with. Isn't that really 7/10? And how would I see which one of these is bigger? Well, I'm not going to do that one for you. But what if instead of 7/10 and 5/7, it said 2/10 and say 1/7, and they wanted to know which one was bigger? Well, if that were the case, I'd change them both into fractions that have 7 as its denominator. 70 as its denominator. This is a pattern of multiplying by 7, and this is a pattern of multiplying by 10. And you would find that 14 is bigger than 10. I'm changing them so that they have common denominators, and that's the way I'd handle number 1. Look at number 2. Explain how to write a percent as a decimal. Well, they're looking for you to write a sentence. They want some sort of sentence structure here. That's why it says explain. But let's talk about how I would change, say, for example, 60% to a decimal. There's a couple ways to do this. One of them in the book talked about just moving the decimal point 2 places to the left. The other way is change it first into a fraction and then divide the top number by the bottom number. But guess what? You'd still end up with 0.60 as your answer. A third way is to think about place values. 60 hundredths. How would I write 60 hundredths as a decimal number? I'd still write it like this, because the 0 fills in the hundredth spot of the place value. Let's go to number 3. Find the prime factorization of 72. I'm not going to do that one. I'm going to do 64. What would that be? Well, 2 numbers that multiply together to make 64 would be 8 and 8. I could break down the 8 finally into 2 times 2 times 2, and I would do that twice, wouldn't I? And so the prime factorization of 64 ends up being 6 different 2's, all multiplied together. So that would be the answer for 64. How would I find the greatest common factor of 24 and 40? That's your next problem, 24 and 40. I'm not going to do 24 and 40. I will do 20 and 36, though. There's 2 methods. One method is using the prime factorization of both of these. I'm just doing factor trees and then figuring out what they have in common and then multiplying together what they have in common. So my greatest common factor is 4. The other method would be to list all the factors of 20, 1 and 20, 2 and 10, 4 and 5, and list all of the factors of 36, 1 and 36, 2 and 18, 3 and 12, 4 and 9. Whoop, almost forgot 6 and 6. And then asking myself, what's the biggest factor they have in common? They have 1's in common, they have 2's in common, they have 4's in common. Do they have anything else in common? Nope. So greatest common factor is 4, no matter which method I use. How about 5 and 6? Changing a fraction into simplest form. Well, that's pretty basic, isn't it? I hope. How about 28 divided by 42, or 28 42seconds? I can look at these and tell that they're both divisible by 7, and I get a 4/6. Hey, maybe I can divide these by 2, and that gets me down to 2/3. There's my simplified form for that. I'm going to pause while I go get a better pen. And I'm back with a better pen. 7, 8, and 9 are asking us to change fractions or percents into decimal numbers. Be careful, some of them might be repeating. I'm going to do one like number 7, 5/9. If I take the top number and divide by the bottom number, I'm going to get 0.5. And do you see that? It's going to keep right on repeating over and over again, isn't it? So this is really 0.5 with bar notation over the 5. How about something like number 8, 4 5/8? I'm going to do 4 3/8. The first thing, I write this as 4 point, and then I work on 3/8. Well, I'm not going to do the whole long division for you very slowly here. I'm going to go through this pretty quickly, but basically it ends up being 3/7/5. So I bring that up, and if 3/8 is equal to 0.375, then 4 3/8 is 4.375. How about 34%? How do I change a percent to a decimal number? I'm sorry, to a fraction rather. Well, just put it over 100 and simplify if you need to. In this case, it ends up being 8/25. How about 13 through 15, where we're supposed to change fractions or decimals back into percents? Fractions or decimals back into percents. Well, if I had something like 8/25 and I wanted to change it into a percent, I'd first change it into a fraction that has 100 as its denominator, and that would be my percent. What about decimal numbers? If I had 0.14, the rule says just move the decimal point over 2 places. That's one way to do it. Moving it over 2 places gives me 14%. But here's another method. I know that another way to write 0.14 is 14/100ths, because I'm occupying the tenths and the hundredths spot. And isn't 14/100ths 14%? What about something like this, 0.204? There's 2 methods, again, I can think of. One, change it into a fraction, and then change it into a fraction that has 100 as its denominator. And if I do that, I'm going to get 20.4%. That's one method. The other method, just move the decimal point over 2 places to the right, 20.4%. Number 16 is interesting. Suppose you're painting a wall that measures 10 feet by 10 feet, and you've already painted 46 square feet of that. What is the percent of the portion that still remains to be painted? That's important, because if you don't understand that, you're going to get a wrong answer for number 16. If the wall is 10 by 10, what's its area? Isn't the area of that shape 100 square feet? They've already painted 46 square feet. In other words, maybe they've painted about this much of it right here. They still need to paint this much right here. How much is this much in a percentage value? Well, the whole thing is 100 square feet, right? And they've already painted 46 of the square feet. They've already painted 46%. You need to figure out how much they haven't painted yet. 17 through 20, you need to change those so that they have common denominators. How about something like 2/5 and 4/9, which is similar to problem number 17, but not exact. I'm looking for a common denominator, which in this case is 45. This is times 9. So I've got 18 here. This is times 5. So I've got 20 here. Which one's bigger? It's got to be the 4/9 is bigger than the 2/5, or the 2/5 is bigger than the 4/9. I'll let you do the last on your own. Thank you. Bye.